Sir, Pradeep Bisen, sir, and welcome to 4-day FTP program on artificial intelligence and blockchain application for food and agri sector during 24th of Jan to 28th of Jan, sponsored by the Atal AICT and organized by the Indian Institute of Plantation Management. And today we have a resource person, Pradeep Kumar Bisen, sir, from SatSure Analytics. And today topic is satellite data and remote sensing for precising agriculture. And little brief about our resource person. And Pradeep Bisen sir is technical director of Geospatial SatSure and experience from 2021 April to till today as technical director. Of course, worked in different organizations like head of the department, other national crop forecast center, and this is about the sir exclusively talk about the how sensoring of agriculture and related this sensor part. And I hope I'm just going to handling the session to the user. Please, the session is your go to user.
Yeah, thank you, sir. Just give me 1 sec. I'm sharing my screen. My screen is visible.
Yes, sir. Yes, sir. Yes, sir.
Yes, sir. Yes, visible.
Yeah.
Can make it full screen, sir.
Yeah, I'm making. Yeah, fine. So today I'm going to talk on about the satellite data and the remote sensing part for the precision agriculture side. So this is the very big challenge because nowadays from the last 3 year or 4 year onwards, the government side also the one scheme is going on. They want to put an effort towards they want to do the farmers income doubles kind of the schemes they are targeting. So for this particular purpose also we have to work on the precision agriculture side. So here the very unique role or the key role is very important role is here the remote sensing side, because on a basis of the satellite data we can cover a very big area very easily, and we can monitor with we can monitor at a continuous basis, maybe daily basis, weekly basis, fortnightly basis, as well as the monthly basis. And we can cover regional level area. We can cover regional level means district, sub district, state. One person can cover the whole area, and he can identify what kind of the situations going on in the agriculture sector. But this kind of the authority, or we can the the authority was not available earlier. Maybe through remote sensing we can monitor at a continuously basis. Even we can provide insights to farmers as well as the government, so they can manage the activity at a near to real time basis. Even they can provide advisory to farmers through the remote sensing data. So I'm going to show you today how the remote sensing can help the precision agriculture side. So here we should know what kind of the satellite data is available right now, and how we can use the satellite data for the precision agriculture sector. So first side I'm going to share the what are the space sensor or the satellites freely available, what kind of the sensors are available. Let's say the microwave sensors, because every sensors have their own limits and the different kind of the characteristics. So on a basis of the characteristics we can decide if there were what kind of the season are going on. Let's say if there were a kharif season where the people are facing, or those peoples or those communities are working in this particular sector, they know the time the people are facing a problem of the cloud cover or the climatic challenges are there. So that time you will not get a optical sensors data. So that time what kind of the sensors they can use, So they can do the continuous monitoring and generate the insights from agriculture sector. So these are the different kind of the sensor of our planet. So here the if you will see from a near surface to up to 36 kilometers height, there were different kinds of the satellites and the sensors are available. From a near to surface side, if you will see the different kinds of the sensors are available. People can use up to 1 kilometer drone, they can use, or the till balloons or the stratoscopic balloons they can use, even the airborne instruments people can use. Then from a 400 to 900 kilometer space side, people can use the polar satellites they can use. And then above 32 kilometers 32,000 kilometers and above, they are the geostationary meteorological satellites, or the geostationary satellites are available. From there we can cover a particular state or the country at a continuous monitoring. Yeah. So these are the sensor types. We can say two types of basically the sensors are available. One is the active sensors, another one is the passive sensor. So active sensor has a own source of light, so they can take a pictures, or we can monitor through the active sensors at a night time also. From a passive sensor, they whatever the they are dependent on the light source, so we can use basically these sensors in the daytime, because they don't have their own source of the light. Then here again, the from a active and passive sensor, we can further divide it in a two different part. One is the scanning type, another one is the non-scanning type. Then scanning also, there were the imaging sensor. Non-scanning side, the non-imaging sensors will come. So in a uh, active sensor side, we can say the radar, where they have a own light, real aperture radars or the synthetic aperture radar. And the microwave radiometer and the altimeter will come in the non-imaging sensor side. These sensors we can use for the uh, oceanography side. And the passive sensor side, again, there where the optical sensor or the gravimetric sensor or the cameras will come, where they don't have their the own source of the light. So these are the sensor types. And then there were a different kind of the platforms are available at present. So they can uh, use this platform, and they can put their own payload, and they can take pictures, and they can complete what kind of the requirements they have. Let's say someone wants to do the aerial photography, then they can use the aerial platform, and they can solve their purpose. Now the what is the remote sensing? So remote sensing, let's say if I'm taking or I'm collecting information of any objects without you know touching of that particular object, or without coming with the physical contact of that object. If I am gathering information or collecting information, like how it's look like, what is the texture structure, what kind of the spectral characteristics of that particular object, how it's look like, what is the color and all. If this information, if I am taking through the without touching that object, that is a remote sensing. So like if I'm taking a pictures from camera, that is also a part of the remote sensing, because that camera itself is a payload. There you can from the camera, we are collecting the information through the visible side. So that part also I am going to show what is the visible side and visible range and all. If you can see the electromagnetic, so basically the sensors or the payload, how they are working. So they are working in this particular electromagnetic spectrum range. So these are the visible range, that range basically where we can see by the the camera, normal camera or eyes, that is the visible range. So this range is line between 0.4 to 0.7 micrometer or 400 to 700 nanometer. And then your after visible range, basically this particular range, if you will go towards this side where the wavelength and the frequency is going to to frequency is going to increase, and your wavelength you can see in the meter. So yeah, that will come the infrared, short wave infrared, then microwave radiometers will come. And from right side of the visible side, you can see the ultraviolet X-ray and the gamma rays. So here you can see the wavelength or the is very high, but towards the this side here the frequency is low, but in the right side where the ultraviolet and the x-ray particular the section, the frequency is very high. So basically in the sensor side, if you will see the sensors, those are used in a remote sensing side. So those sensors are available, the wavelength basically is available from a visible to microwave or the up to radio wavelength is available in a sensor side. So radio wavelength basically people are using for the communication side. Microwave data, microwave wavelength is available in a microwave data site or the microwave sensor. This infrared, shortwave infrared, and the visible range wavelength is available in the optical data site. So these are the electromagnetic spectrum. On a basis of the electromagnetic spectrum only, we are getting information of the particular object, how it's look like, what is the texture, what is the color, and all. So the how we are measuring the things through the electromagnetic, the measuring property of the Earth atmospheric system from a space. So you can see here, first thing is the whatever, if let's say we are using a passive sensor where they in a passive sensor they don't have the own light source. So whatever the sun rays is coming from a sun, the incoming solar radiation can absorb by the cloud, and the some rays will come on a ground. And then once those rays will come on a particular object, and when that rays will go to sensor, and the sensor after emission of the these particular rays will absorbed by the sensor, then there were a lot of deviation, emission, or the things will come, because due to the atmosphere, these things will come due to the cloud absorption, or the different types of gases are available out in the atmosphere. So due to that one, the rays may be deflect, absorbed, or or the aerosol emissions. Lot of things will come due to that one. These things, the exact picture, some kind of the exact picture of that particular object we can't get, or we can't capture through the satellite data. So in that particular part, that kind of error, how we can remove. So there were a different kind of the processing is required to remove those types of the error from a satellite data. Okay. Now the once, if you will see the what is the process of the satellite data. So once the satellite data measured the spectral radiation, then the the what is the radio transfer theory and the retrieval algorithm and geospatial parameters and application. These are the whole process. So let's say from here you are getting a satellite data in a different kind of the range, maybe a different kind of the processing level you will get it here. From there, once you will do there, let's say you are getting a satellite data in a L0 level. Level means a raw level. Then L0 to L1, L2, L3, different kind of the processing is required. On the basis of the processing, we are providing our levels. On a basis of the level, we are deciding, okay, what kind of the data we are taking for the further processing. So these are the different kind of the types of the satellites is available. For the communication satellites, there were a different kind of the range is available that we can using for the television purpose and all. Then weather satellite, navigational satellite, then earth observation satellite. So in a remote sensing, basically we are using the earth observation satellites, where that particular satellites in a range from a visible to microwave wavelength side, or these satellites wavelengths are available. Now the what is the spatial resolution spectral? So these are the sensor specification basically. The spatial resolution, spectral resolution, temporal, and the radiometric resolution. So spatial resolution means it's showing the what kind of the 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 characteristics of the satellites, satellite resolution site. So let's say I have a satellite sensor, and I can, if I'm telling the satellite resolution is a 20 to 50 meter, means whatever the pixel size of the particular satellite is a 250 meter, means whatever objects are available above 250 meter on a ground, we can capture easily on a satellite in that particular satellite. If my spatial resolution is a 10 meter, then whatever objects are available 10 meter and above, that I can capture very easily through that particular satellite data. Then second is the spectral resolution. That is the ability of sensor uh, to the spectrally, means if let's say I have a one spectral range of that particular satellite, or the if there were in a satellite there were 10 bands, and the spectral range will start from a 400 nanometer to 1200 nanometer. So each and every band wise, what is the spectral range? If the spectral range is high, means the spectral bandwidth of the particular band will segregate in a very nano range, so, or the very specific range. So we can collect, or we can get a more spectral characteristics we can capture very easily through the spectral resolution side. Then third is the temporal resolution, means let's say if I am taking a one picture from today, then on a from a same object picture, if I am taking uh, uh, after 3 days, means that is the temporal resolution of the satellite data. So what is the frequency of the particular satellite to pass that particular object? That is the temporal resolution. Then the radiometric resolution means the ability to difference the energy, means if I'm taking a satellite data in a 8 bit side, or the 10 bit or the 12 bit, means from a same object, if I at a what level I can segregate. So that will give the radiometric resolution side the information. Now the spatial resolution side, what I told, if the spatial resolution low, means your the pixel size will be very coarse or very big, greater than 1 kilometer, means I can see the the particular object whatever is above the 1 kilometer, that I can see the in this particular side. But the very high resolution side, where the spatial resolution is very high, means less than greater than 5 meter spatial resolution or like that. So now what is the specialty of this particular spatial resolution site? If let's say one satellite where the spatial resolution is low, that particular satellite can cover a very big area. But if the spatial resolution is very high, then he can cover a very small area of that particular satellite. Okay. Now you can see the spatial resolution example. This is the let's say this is the one particular palm tree area. When the spatial resolution is very high, we can see very easily the palm trees. But where the spatial resolution is low, let's say 20 meters, then we can't see the palm trees very clearly. So these are the difference from a spatial resolution side. Now the characterization, this part I already covered earlier. So application side, we can see, the satellite data we can use for the different purpose in a weather side, land mapping side, atmospheric physics side, air quality side, and all. Now the common orbit type, there were two orbits. That part also I covered earlier: geostationary orbit and the polar orbit. Geostationary orbit, where the range from a 32 kilometers, 36 kilometers above the equator, where the geostationary satellite, basically you can see in the polar side 600 to 1000 kilometer, uh, the height of the satellites from Earth. So these are the polar sensor observation frequency, if you can see here. So polar orbiting satellite 1 to 3, the observations we can take up per day per sensor wise, and how it's look like, we can say. So these are the hours, these are the micrometers. So on a basis of that, we can collect the information from a observation frequency side. Now the coverage of the spatial resolution, what I told earlier. If your spatial resolution is low, you can cover a more area on a ground. If your spatial resolution is very high, you can cover a very less area on a ground, but you can see the object very clearly, because here the spatial resolution is very high. So these are the difference. The multispec, here the sensor used for in a remote sensing satellite that I told already: the panchromatic camera, synthetic aperture radar, microwave remote sensing, multispectral scanners, and all. Now the multispectral scanners, what is the multispectral scanners and how it's user, how it's work? So you can see this is the swath, and this is the direction. So there were two types of the scanners is basically used. One or two types of the scanners, basically you can see, and on a basis of the scanning, they we can differentiate. One is the push broom, another one is the whiz broom. So along the track and the across the track of the sensor, on a basis of these characteristics, we can tell, okay, this particular sensor is the push broom, this particular sensor is the whiz broom. So along the track is the push broom, across the track is your whiz broom sensor. Now the multispectral sensors, you can see these are the some kind of the example. If anyone wants to use, they can use it. The multispectral sensors, the Landsat series, you can see. From a Landsat series side, again the wavelength, what is the wavelength, and how it's particular band wise, what is the number of bands, and how we can use it. So let's say if I want to do the analysis for the particular area, what kind of the forest changes is going on over the time period from 1980s to 2020. So for that particular purpose, definitely I want one time series data. And for the time series data side, definitely the same sensor, if it is available, then I don't have to do the any kind of the processing like a normalization, because if your sensor will change, then definitely your all the sensor characteristics and the properties, everything will change. Then we have to do the normalization to put the both sensors, the resolution, spatial resolution, spectral resolution side. We have to do the processing is required. So if we want to ignore that kind of the processing, then we can use a single sensors, we can use to do this kind of the activity. Now the thematic mapper, why the thematic mapper is required? So if we have a thematic mapper, then the we can collect a land surface temperature easily, and from a land surface temperature we can use different kinds of the purpose. We can we can do in agriculture sector, even the water resource sector also. So these are the micro radiometers, thematic mappers. These are all are the sensors. So here the if you I told earlier also, microwave radiometer, what is the use of the microwave data? So microwave data can penetrate very easily through cloud, and especially in the kharif season when the cloud cover is very high, and we can't take a satellite. We can take a satellite data, but there you can see the cloud cover, especially in the optical data side. So that time we can use the microwave sensor, and through the microwave data we can penetrate. We can get a continuous data, and we can do the analysis or the monitoring, or at a continuous basis, and we can generate the results easily through the macro data. And same thing from the synthetic aperture radar side also. The SAR data can penetrate easily the cloud cover, and we can generate a different kind of the insights through the SAR data. Now this is the another one example how it's look like when the optical data is not available that time. If there was the volcano eruption is going on, then we can do the analysis what kind of the impact of the volcano. These all studies we can do very easily through the synthetic aperture radar or the micro data side. Now the panchromatic data. What is the panchromatic data, and why people are using the panchromatic data? Because it's very high spatial resolution, and it has a one band. So if it is a one band, then we can see the objects whatever whenever we are capturing the images through the scanner or the camera. That time we can take a pictures in a grayscale. Grayscale means black and white range only. The spectral band range will be high, but the we can't take the color images through the panchromatic camera side. So this is this camera is quite sensitive compared to uh, the optical side, because in the optical side there was a red, uh, uh, red, blue, green, near infrared. There are n number of bands are available, and those bands basically is has a very limited spectral range. So we are not able to get a capture or some spectral characteristics through those particular bands. So that time we can use the panchromatic camera, and we can capture it very easily. And how it's work, especially in a cartoset one that is available in the RS5 P5 sensor. So from there we can take a the panchromatic images, and that panchromatic images we can use very easily with the other satellite data. If we want to increase the spatial resolution of the particular sensor, then we can use the panchromatic band, and we have to do some kind of processing. Once you will fuse the optical or the multispectral data with the panchromatic data, you will get a very spatial high resolution panchromatic data, and we can monitor very impactfully of the particular satellite, particular area or the region. Now the payloads, these parts I don't have to cover because this is something very different. So here you can see the how it's look like the payload, what are the antennas, how we are fixing the whole part. So these are the components. What are the antennas, payloads, bus, solar wings. So this whole part uh, as a payload. So on a basis of that only we are capturing the images. Now the data analysis part, we know once we'll get a data from a satellite data, then here the data source building, and these are the different layers we can classify easily. Now the these are the backgrounds. So you know how we are how we have to do the data analytics from a satellite data. If we want to generate any insights for the different verticals, then what kind of the the data sets we have to select, what kind of the processing is required, and on a basis of the our goal, how we can achieve the goals through the data analytics side. These parts and the techniques it's here I mentioned. Now the spatial analysis in a GIS setting of the objectives. So let's say you know the Earth, how it's look like, it's undulating and all. So we can see the different kind of the features on Earth. So different kind of the features, if we are going to capture or mapping, then what kind of the layers we have to generate one by one. And once you will generate all different layers, then how we can do the superimpose, and we can generate a combined layer to generate to serve the different kind of the insights we how we can generate here we sorry. Now this is the analytics, what kind of the processing is required, and what kind of the error corrections are the required during the data processing time and the data analytics side. Here you can see, once you will get data from a satellite, so that is the L0 raw data. Then geometric corrections, spectral corrections, radiometric atmospheric corrections, missing pixel restorations, image contrast enhancement, and the filtering is required. Once this all process once will complete, then only your satellite data uh, is ready to use for the particular purpose. Let's say if I want to do the agriculture side, I want to use the satellite data in the agriculture side. Now I'm getting a L0 or L1 data from a sensor. Then definitely because once you will import that data or the superimpose on a earth, that data will not sit properly on a particular place. So there were a geometric error. So definitely once I will remove the geometric once I will do the geometric correction, then only the satellite data will sit properly on a ground, and it will show the exact picture what's going on in a earth. So like this, if you will see the right hand side, if I want to generate a different insights through the satellite data, then image, this is the satellite data. Then here the pre-processing is required. This kind of the corrections are required. Then once you will complete this correction, then image enhancement once you will do. Then the ancillary data, if let's say there the in situ data is available, then you can use the in situ data or the reference data to make a library. Like if let's say if I want to run a AIML algorithm or any kind of analysis I want to do, then definitely the reference data and ancillary data is required. Then on a basis of the ancillary data, we can do the image analysis, and after that we can generate different kind of the the library, and we can run the supervised classification, or if we don't have the library, then we can do the clustering, that will go under the unsupervised side. And on a basis of that clustering, we can generate a different kind of the insights, like we can generate the maps, we can generate the images, or the classified images, reports, or data we can generate it. So these are the common process whenever if we are generating a report, say, or we are doing a monitoring of a particular area, then these are the common steps are required for the satellite data site. Then these are the suitable analytics techniques. So let's say if we are doing a classification, or we are analyzing any particular uh, satellite data, then color transformation, indexes, images, spectral unmixing, these are the techniques to do the analysis that particular the images, or how we can do the if we, let's say, if I want to classify one particular satellite data. In a satellite data, let's say I have a 20 kilometer by 20 kilometer picture. So whatever things are available on the ground, that I can see on a picture, but my area of interest, let's say agriculture, then my target area is agriculture, then definitely I have to generate a training data. On a basis of the training data, I can uh, I can classify, or I can get only those information what is on a basis of my area of interest. Now this is the, for example, if I want to do the forest fire mapping and the monitoring, so you can see the natural color satellite data. Once I will generate a false color composite. False color composite means I have a three channels, visible channels: so green, red, green, and blue. So my infrared band, when I will pass through the red channel, my red band, I will pass through the green channel, and my green band, I will pass through the blue channel. Then I will get a false color composite image. So in a false color composite image, you can see the how it's look like. So if there were vegetation, right, so that will come in a red color. But in a natural way, if you will see the vegetation on the ground, it will look like a green color. So this kind of the difference you will see when you will generate a false color composite image. Okay, so this is the flood mapping monitoring side. This is on a basis of the microwave data, because optical data is not available that time, because there where the full cloud cover is available. So how I can get the if I want to do the damage assessment due to flood, then how I will do. So on that time I will use different micro data there. So micro data, you will not get a band. Basically there you will get a polarization. So let's say, what is the polarization? So there in general, in the microwave data, there were the four kind of the polarization: HH, HV, VV, VH. So what is the HH, HV, VV, VH? So let's say uh, I'm let's say if I'm talking about the HH, so whatever the rays are coming from horizontally, and I'm receiving through sensor horizontally only, so that is the HH. What is the VH? The rays are coming vertically, and in a sensor I am collecting horizontally, that is the VH. So like this, there were the four polarization. So on a basis of the polarization, there were the different kind of purpose also. Let's say um, the in general, in agriculture, basically people are using the HH or HV polarization generally. If I want to do the analysis of the flooding, that time I will use VV or VH. polarization. So there were a different purpose also of different polarization wise. Then this is the tropical cyclone mapping, how it's uh, before tropical storm and the after tropical storm, how it's look like. You can see very easily here. Now this is the mapping monitoring of the rice field damaged by the hailstorm. You can see this is the indices, this is the time series indices also. So how it's going to change. So what is the how much area has been damaged uh, after hailstorm. You can see here very easily at a farm level. So up to farm level information we can easily capture through the satellite data. These examples you will get it in a next slide also. So this is the usefulness of the data analytics part. Why the data analytics part processing and the multiple things are required. Here we can see easily. Now the case studies I'm going to show. So on a basis of the satellite data, how we can use and we can generate different kinds of insights in the agriculture side, and how we can use these insights for the precision agriculture uh, uh, side. We can use I am going to show in the case study side. So so this is the space data application side. We can use in a different verticals, agriculture, infrastructure, and the climate side, but here we are focusing on the agriculture side. So we can do the crop damage estimation, crop life cycle monitoring, yield prediction, area estimation, sowing, harvesting prediction, and the pest prediction through the satellite data. And these are all parts or the all things basically we are covering in a or SatSure Sage. This is the one particular product is available on our market. So anyone, if someone wants this kind of the insights, if someone wants, so they can take it very easily through this one. Now in the agriculture case study side, through the satellite data we can estimate the acreage estimation, showing progress, how the let's say this is the whole district, and I want to cover a whole district, and I want generate insights, or I want to cover a whole season. So I am alone, but I want to cover a whole district. So how it is possible? Through satellite data only it is possible, or the remote sensing. Because if I want to cover the whole district physically, that is not possible. If I can cover one time within a season, but what kind of the situations are going on in a one particular place or one particular village, how I will get it those information. So those information, it is not possible physically. Even if I will deploy 15 people also, or the 20 people, they will not get a exact information on a ground. So that's why through the satellite data we can do the acreage estimation, showing progression, prevented, showing crop health monitoring, crop damage, harvest progression, harvest readiness, and the relative yield. This all information we can generate through the satellite data. And because the here the spatial resolution of the satellite data is a 10 meter. So whatever things are available on a ground at a lowest pixel size, let's say 10 meter by 10 meter, I can generate the insights, and timely I can monitor over the whole season, mm, very easily. And this is very effective, the process or the tool we can say. Because let's say if I want to cover a whole state and I don't have the let's say this kind of the situations going on right now, the COVID situations are going on. So people are not interested to go outside. So in those cases, how we can monitor if there were some kind of the situations are going on the ground. and the farmers or the other peoples or the even the government want to support, then how we can do it. So this is the one very good application or the example, you know, from a satellite data side we can use it very effective manner. So this is the state government pilot projects also be completed. So they want to know what time they want to do the sowing. So this from this way they can see, okay, this particular time this particular village is feasible for the sown. So this information we can generate very easily. Even every village level we can generate which particular village there where the stress conditions are, if is going to farm, if the stress conditions are is going to farm, then what is the how much area is coming under the stress condition. These informations also we can the insights we can generate through the satellite data or the remote sensing. So this is the another one is a classic example of the pest condition estimation. So these are the villages within a taluka. If the at a village level, if I want to provide a pest condition estimation for the particular crop, that also insights we can generate for the farmers, and we can provide the advisory also. This is the another one example for the crop damage assessment due to the you know uh, if there were a Titli cyclone came in Ganjam district. So how much area has been damaged due to cyclone, and what is the impact of the cyclone? This part we can easily estimate through the remote sensing, and we can tell how much area has been damaged due to cyclone at every the block level or the village level also. We can say how much area has been damaged, 10%, 5%. If we want to estimate the damage area in a area wise, how much hectare has been damaged and what is the intensity, this part also we can do it very easily. Now this is the another one use case from the regional level monitoring side. Let's say these are the different districts, and I want to monitor and I want to estimate how much area crop wise area is there in that particular that particular district. So on a basis of these estimations, we the government or the particular agency they can do the uh, planning. If let's say the normal area is coming under one particular crop, let's say 1 lakh hectare, and they expected if the 2 lakh hectare area will come a particular crop, then only they don't have to do the planning for the things. So this part also they can easily they can do the planning, monitoring, and the kind of the if there were some kind of the damage and other natural calamities is coming, they can easily monitor and they can manage also. So this is the another one example, classic example. If we want to do the farm level monitoring, what kind of the situations are going on at a farm level. So this part also we can cover it very easily within a farm, which particular pocket is affected. This part also we can cover it with very easily through the remote sensing, because the from a negative we can't we can't know, because it's from a negative we can see only the visible range. So we can say, okay, this particular farm is it's look like average or proper, but what kind of the stress is going on we can't get it those information. But through remote sensing we can get it very easily, and we can cover the whole area. Then the crop stage identification within a region. So within a farm, the farm level, we can know which particular farms are in a which particular conditions. So this part also we can cover it very easily. Which particular farms, what kind of the management practices are going on, where the sowing, planting, heading stage is going on, heading, or the harvesting, where the harvesting is going on, and at a what date its harvesting is going on. So this whole time period we can easily cover, and we can understand which particular farms are coming, what kind of the the farming activity. These all things we can get it very easily through the satellite data. Now this is the yield estimation side. We can estimate the yield at a village level. This is possible through the remote sensing data. Even the government is continuously doing the CC, crop cutting experiment, but they have a very limited resources, so they are conducting a 4 crop cutting experiment in a one particular gram panchayat or a village level, and on a basis of that they are extrapolating at a block level and the sub district and district level, and they are generating the yield. So if we want to know the very accurate manner, what is the yield at a village level or at a farm level, so we can calculate very easily through the remote sensing. And this yield we can calculate before 1 or 2 months of the harvesting. We can we can provide a forecast, or we can generate the yield through the remote sensing. Now this is the another one case study in a water management side. If we want to do the precision, if we are talking about the precision agriculture side, then this is the one main factor where we have to take a decision, and we have to manage the the water management side. We have what how much water is required in a one particular village or the pocket. So these studies also we can complete, and we can generate the water demand through the remote sensing. And so the very district or sub district or the state also we can manage very easily. Now the disaster management side also, through the remote sensing data, we can cover the whole Kerala, and we can generate the insights near to real time basis, and we can provide the these insights to governments or the different NGOs or the agencies, and they can manage the whole activity on a basis of the what kind of the situations are going on our ground. So this is the about SatSure, and how we are available in a and globally recognized we are. So these are the two things, and two products, and the two patents, or in a processing stage also. So these are from a SatSure side. If any questions or anything is, if you want to ask, so please. Thanks.
Requesting a participant, can you please have a questions?
There is one question in chat window. You can check it, sir.
Chat box, sir. Chat box, sir.
Oh.
Sayed, there is.
What is the question, sir?
I'll paste it and you check the chat window, sir. I'm sending one more time. Under retrieval algorithm section, do we use AI-based algorithm for information retrieval? What are the algorithms which are effective in it?
Yeah. So for the AI-based algorithm side, so let's say what kind of the algorithm if he is talking about, then if let's say if we are using a time series data, then time series data side they can use a different kind of algorithm like a random forest or other kind of the algorithms they can use easily. If what kind of the data sets people are using. Let's say if someone wants to generate a insights through a one or two satellite data, then simply he can use unsupervised AI ML algorithms he can use, and he can generate the insights. But if someone wants to generate the insights through the time series databases, then he has to use supervise, and the different kinds of the algorithms and the libraries are also available, so he can use it. So like just now I gave an example random forest site, because it's available on a time series data set. Here in a random forest site, people can use the time series data easily, and they can generate the insight. So only here the if any algorithm, let's say AI ML based algorithm, machine learning, or the artificial intelligence side, what kind of the insights we are going to generate, first thing. Second, what kind of the data we are taking. So here the data and the in data is a one crucial part, because on a basis of the data you can decide what kind of the algorithm you have to go, because there were a number of algorithms. So some people are using, you know, uh, uh, the maximum likelihood, they are iso data clustering. There were a lot of algorithms they are using. So these are the parts, or the spectral angle mapper, SPM, support vector machine. There were a number of algorithms. So it depends what kind of the insights and the data we are generally using. Climate change is unpredictable. How affect the remote sensing behavior? Okay, so because the climate change is the unpredictable, definitely. So from a remote sensing side, if you can see, you can take a different kind of the the sensors we can use it, because the sensors, though, from where we are getting uh, the data images that will come in a near to real time basis. But the climate change is the unpredictable. Then what we can do, we can use the climate data or the forecast data. With the forecast data, when we will club with the remote sensing images, that near to real time images, on a basis of that we can, you know, generate the insights very effectively. That is the one thing. The second thing, we can, on a basis of the remote sensing images, because those images we are getting real to near to real time basis, and the time series data we are using. So on a basis of the near to real time databases and the climatic data, we can generate insights. Okay, after 3 days or after 4 days, what kind of the situations can happen, that kind of the predictions we can generate through the remote sensing. So those kind of the things are possible. But yeah, so if we those kinds of the situations will come in the future, you know, next 3 days basis or 4 days basis or the 8 days basis, so we can take some kind of the precautions or the measures we can take easily. Same examples I showed in uh, when the Kerala flood happened. So that time, so you know, everywhere was the flood was there, and no the uh, physical connections was very limited. So they want to manage the whole Kerala. So that time we use a remote sensing data as well as the other ancillary data, and we provide our solutions to government, and they manage very properly with the limited resources. So these are the effect, the effects we can change. So from there, the flood was the flood impact was very severe. But on a basis of these two things, within a 3 or 4 people, we are able to manage the whole Kerala. So these are the effects from a remote sensing side. Yeah. Any other question?
That is really amazing, Mr. Pradeep. I have one more question. For example, see, in the recent past, right? I mean, if you take typically Chennai, for example, I'm taking an example of Chennai. In the recent time, right? Even the Indian IMD was not able to predict a rain. Okay,
Yeah.
They said that they didn't have an equipment. So in those kind of scenarios, can the farmer rely on SatSure to say like, okay, they're able to predict much more better than what IMD is trying to do? Because IMD openly saying that they were having lacking equipments. So in
Yeah.
those kind of scenarios, because the flash floods or the the kind of rain will sometimes even the IMD is not able to catch up.
Yeah.
So
So in these cases, let's say we have a near to real time data or the past data, right? So on a basis of the satellite data, because what we can do from a satellite data, we can do the topology and the topography information. We can get it very easily, right? And once you will get a what kind of the slope is there, what kind of the crop people are growing, and what is the frequency of the flash flood and all those information. Once you will get it, you have to club, or what we did, we clubbed those data sets with the climatic parameters like a rainfall, the humidity and all. And on a basis of that, we generated the simulated model. So on a basis of the simulated model, we can tell, let's say, if the rainfall that particular area will receive 100 mm or the 50 mm, then what will be the extent of the flood? Where is the chances of the high severity and the low severity? So those kind of the predictions is possible, and those these insights basically this year only we provided to the Maharashtra to manage the farmers crop, as well as the as well as they want to manage the activities from a government side. Those insights we provided.
okay, thank you very much.
So here we have to use the simulation modeling, because nothing is very accurate. If we are talking about the forecasting, then definitely there were some chances, but up to what extent we can generate the insights, at a what level of the accuracy we can provide, that is also depend on the data sets and the algorithm.
Yeah, any other clarification from participant?
Any questions from participants?
Okay, sir, there are no questions.
Yeah.
Thank you, sir, on behalf
Thank
of FTP team, sir. Really wonderful session, sir. The practical way how you just shown that remote sensor, how seeing and using of the techniques, everything. Hope all the participants also maybe learned new things. So further we'll have a collaborate with you, sir. Further, any research projects or any like
if any questions, so please feel free. They can reach to me, and
yes, sir.
Explain. Yeah, thank you. Thanks to all.
Thank you, sir. Thank you very much.
Thank you so much, sir. I think it has
Yeah, thank you.
I think around 15. We have one more session by Cropin. Yeah,
Cropin.
Yes.
Yeah, thank you.
Thank you, sir. Thank you.
Thank you, sir.
Dear participants, yes, we will have 11:15.
5 minutes will have break, and 11:15 will start.
We'll start. Please stay on, and we'll start at 11:15. take 5 minutes break. See, another session also, we have another feedback, attendance also.
Hello. Good morning,
Good morning,
everyone.
sir.
Yes, hi. This is Praveen here.
Yes, sir. Yes, sir. I just made you co-host, sir.
Okay.
So we will start by 11:15, sir. Just be informed to all participants. They may
Sure. Yeah, I'll be
You
on
check-
mute.
you
I
just
just
check
wanted
it.
to only check the audio, and let
Yes,
me
sir.
also try sharing my screen.
Yes, sir. Yes.
Right, just give me a second.
Good morning, sir. Praveen, sir.
Oh, hi, Professor Ganesh.
Yeah. Thank you, sir. Thank you for your time.
No problem.
A lot of time because we want to learn from this Cropin, sir. Cropin doing amazing thing in agriculture. So
Yeah, sure. Thanks so much. As I mentioned, the last week or so, I've been sick.
yes,
I just got back to work only today morning, and this is the first meeting that I'm taking. So just give me 1 second while I share.
sir, make him as a co-host, sir.
Yeah, all done, sir. Done, sir. All done.
Yeah.
Health is fine, sir. Now, somewhat.
Yeah, I'm still recovering, but yeah, I'm taking it slowly.
Thank you. Thank you, sir. Thank you very much.
Yeah.
I think Ganesh also tried a lot, sir, for you.
No problem. Actually, like I would have been very glad. The only thing is, unfortunately, this period, like last 1 week, I've been down.
Okay.
Yes, sir.
So share screen. And let me see if this one works. Let me know if you see my screen.
Yes, sir. It's visible.
It's visible. Okay. So whenever you're ready, we can start.
So we'll start, sir.
Yes, sir. I think we can start, sir. I think we
Yes,
are
sir.
15. We'll start, sir.
There was
So,
a
yes.
break, is it, like in between?
Done, sir.
5
Done.
minutes. 5 minutes was break, sir. We
Okay.
planned 11 o'clock, but 11:10 only we completed the first session. 5 minutes.
Okay, I can wait actually, no problem. I have some buffer time even after this meeting. So.
Okay. If you want, we'll wait for another 5 minutes or 2 minutes. Wait.
Okay, yes.
How many participants are there? 72.
72.
Yeah.
We'll start 11:20, sir.
Yeah.
Yeah, 11:20 will start. Is it okay, sir? Wait, sir?
Yes, sure.
Praveen, sir.
Yes.
So while I think people are joining, one interesting thing is I'm actually in Kengeri, yeah.
Okay.
So often when I travel to the city, I see the IIPM, and so I'm reminded of Professor Ganesh every time I pass through that.
Okay, sir. You
Yes,
stay
sir.
near to our okay. Thanks, sir.
Yes, yeah. One other thing is, I think if I forget, I wanted to also mention that, I'm also asking, I mean, this would be a tutorial, but I'm asking my HR team
Okay, sir.
to reach out to you as well, because we have also many open positions,
Okay, sir. Okay, sure.
in which like there is we have some fellowship programs.
Okay.
And we have like also permanent positions, full-time positions.
Okay.
Mostly these currently our openings right now are in the in three areas. One is in sales, in marketing, and mostly in client interactions.
Okay.
So those who have, I think who would be an ideal candidate is those who have agriculture background, either in their education or something, and who have technical, background as well. So a combination of that, where, like it would be really like useful where there are many agri-tech companies. There are many development agencies, and all of these agencies will reach out to us, anyone who has expertise in agri-sciences, in remote sensing, satellite imaging, and in technology, with engineering background, all of that. If they can actually also, I'll actually share my email address. I'll share an email address. Vinay is the one who is taking care of it.
Okay.
So they can actually like reach out to him, and we have like a lot of open positions throughout the year.
Okay, sir.
And I'll share that with you, Professor Ganesh, and
Yes, sir. Please, sir. Please.
Share it with everyone else. No?
Yes, sir.
After this call, after this meeting, I'll share it with you.
Yeah, definitely, sir. Some of our students are working, sir. Some are Sumesh, another one is Nagabhushan.
Oh, yes. Yeah, we do have like a lot of earlier your alumni as well joining IIPM, and so it'll be good to have that kind of continuing partnership. I think like Vinay will be taking care of that, and I'll introduce you all, even for those who are in the call, maybe not only from IIPM, because we are looking from all over the country, so they can actually reach out to Vinay.
Yes.
Okay. Or maybe add his email address in the
yes, sir. Please share, sir. I will keep in touch with you, sir.
Okay, sure. Just see. Just give me a minute, and then we can start.
Yeah, got the mail ID, sir.
Yeah. So you can reach out to him. It would be difficult for me to process all the emails.
Okay.
He would be the right person to.
Yes.
Okay. And for today's talk, this tutorial session, Professor Ganesh, please do indicate, and maybe I'll also ask the audience as well, because I'm not familiar with what their background is.
Okay.
So I think they are professors,
Yes, sir,
teachers
yes.
from all backgrounds, right? Are they like from agriculture background, from what is the diversity of the background? I like that I can actually like fine tune, because we have only an hour.
Okay,
So I
sir.
just want to ensure that I am able to reach out to them.
Yes, sir.
And
Mostly
it's
they are
not too technical or too boring either, you know.
okay.
Yeah.
Yeah, you can talk about
Sir,
your.
shall we start?
Yes, sir. I just to brief you the participants, sir. Mostly
Yes.
this scholar and faculty members, sir. Mostly their background of agriculture and food science.
Computer science of some people.
Multidisciplinary, but you can talk about how a Cropin is solving a different agriculture problem. That will be fine, sir. What are the different products they have, and what are the different agriculture issue, food issues, and traceability issue or something. You can talk about your company, sir. That will be fine, sir. Use cases.
Okay, sure. So shall we start, sir?
Yes, sir. Yes, sir.
Yes,
Sir,
sir.
on behalf of FTP, I welcome you, sir. So this is 4-day FTP program on artificial intelligence and blockchain application for food and agri sector during 24th of Jan to 28th of Jan, sponsored by the Atal AICT and organized by the Indian Institute of Management Management, sir. I myself as a co-coordinator, and I want to introduce about our participant that rightly already Ganesh sir explained all the academicians background. And today we have Dr.Praveen P from Cropin Technologies. He's going to be talk about AI and blockchain technology case related lecture going to be talks, and a little bit brief about the Praveen Kumar sir. Praveen Kumar P. Dr. Praveen Kumar P is from Cropin Technologies. Praveen Kumar is now as Vice President for Data Science and AI at Cropin in India. Prior to this role, he was the lead for data science and machine learning with Karteva Agri-Science, Hyderabad in India. He has worked in the area of application of signals and imaging processing, pattern recognizing, and machine learning to a variety of domains such as oil and gas, utility, power industry, life sciences, agriculture, and healthcare. As a part of the job, he has experience in working with research from Europe, Asia, Israel, Korea, North Africa, and USA, with special focus on imitating and sustaining the project collaborations between the academia and industry. This is a brief about our resource person. Hope this session will be give you more in-depth knowledge about the AI and blockchain application by using of some cases. Now, session over to you, sir. Praveen, sir.
Okay, thank you so much for the introduction. There is no Kumar in my name. It's only Praveen Pankajakshan. My last name is a little bit difficult to pronounce. Praveen Pankajakshan. You can just call me Praveen. Yeah, thanks for the introduction. So I'll be very brief with what we do and everything. I've kept the chat window also open. I hope it's not blocking the visibility of the screen, so that I can. Okay, I'll just close it actually. So if you have any questions in the middle, please do stop me. I really don't mind people stopping me and during the session, and let's make this more interactive. No questions are, I think like all questions are welcome. I think they always say, right, the ones non-asked are the ones is an opportunity lost, for me also and for you also. So I think I also learn a lot from this, and maybe the future sessions based on your feedback, we can actually like structure it differently, So usually when we do this kind of tutorial, we also try to make it more hands-on, I think, so that you can also try something and everything. But I think under the current online scenario, it would be a little bit challenging. But we'll maybe in the future sometime we will actually do that, because when you actually also work with the data, you will also understand the challenges, and sometimes very small data set itself you'll be able to figure things out, right? So today's presentation more is on something called Cropin Cares. It's crop mapping using AI and remote sensing for eco-agriculture and sustainability. This is not my work alone, so I'd have to also mention that from left to right, so Shabri, Arvind, Shabrinath S. Nair, Arvind S. and Jitendra Kumar Oja. These are actually very, very close partnership in all the work that I have done here. So kudos to them. A lot of credit goes to them, and I'm just here, the front face for it. My background is on data science and machine learning. So Arvind leads the Earth Observation Sciences team, while Shabri is actually takes care of the currently the AI science team within Cropin, and Jitendra is a product and innovation lead, so taking care of our product side and at the same time research and balancing between both, right? So we have a very, very strong team within Cropin for both Earth observation and AI science. I just want to start with one particular statement, and working with the agriculture and also in this whole domain now close to more than 5 years, and maybe excuse me because I might not be as experienced as some of you here in this call, but I've actually in the past 5 years itself, I've witnessed a lot of changes, and I like this quote from the Director General of WWF International, and I've underlined the most important points that I feel very close to. And I think it's also something within this particular group to reflect on, considering that everything that we do is going to have an impact on the earth, right? Especially food. So I'll just read it out, so that I'm not misquoting. Food today generates a heavy environmental footprint. A shift to sustainable food systems is essential and includes sustainable production and harvest on land and at sea, integrated land use planning, land and marine restoration. We need progressive regulation, smart land use governance, technology innovation, behavioral change, and multi-stakeholder collaboration. The reason why I've underlined all of this is that the whole idea of agriculture, as we know before, intensive agriculture and everything is actually changing, and people are more and more realizing that, that's an old paradigm. We cannot actually sustain the same paradigm anymore. And we see this in our daily interaction with our different clients, with everyone is working hard towards moving into sustainable production, and it's not going to be easy. And, I think there is a wrong, maybe a notion that maybe not with everyone, but wrong notion that technology is going to solve the problem, So this quote is very important because it really strikes at the core, and each and every word is well thought about. And, it really drives home the point that technology alone is not enough. Technology innovation is important, but it also, we also need to understand how to bring a behavioral change, how we can collaborate together. The reason why we do all of this is that I cannot do this on my own. We need to work and solve this problem together, right? And this also needs also governance, how to use it, right? How to use the land. And I'll talk a little bit about all of this later on as well. So this is very, very important. So let's not, start. I don't want to give this false hope in any way that technology innovation alone is going to solve the problem. While that is important, I think it's very, very important for all of us to be on the same page that alone is not sufficient, right? So just maybe for those who don't know about Cropin, I'll just give a very brief introduction. Cropin is actually an agri-tech company, and in the past we have been actually working together to solve some of the major actually agriculture problems in the world. And in the past we've collected a lot of data, from digitizing farmer fields. This is one mission statement that we want to go with. While sustainability is very, very important, we believe that every single pixel in the world has a story to tell, and we want to find every single story in the pixel from remote sensing, right? And that's our actually a larger mission statement. And this cannot be done from the ground alone. We need to have our eyes on from the sky as well, right? From the space. Now, how do we actually this is a very simple slide, and we believe in for the past 10 years or so, we have been building one of the largest data moats, which includes, like I mentioned, going and digitizing farm fields. So we have trillions of data that's sitting in our databases, and these are, very well tagged data set. And I'll talk a little bit about tagging of the data set and all of that later on, and how that's becoming important. And, we have actually proprietary algorithms and also stack to actually work on this, using satellite images. And we have actually built also our models based on, we are also now building the largest ag knowledge, engine system. And all of this is actually brought together, and I'll give us little demo of how our system platform works as well. This is not going to be a marketing kind of thing, but it's more to give you some real world perspective on how challenging this problem really is. I don't think I'll have time today to talk a lot about I don't think I'll have a lot of time to talk about blockchain, but maybe that can be part of that related to traceability and everything can be later on, right? So I talked about a lot of data set which we have, and this is one of the most probably critical differentiator within our particular Cropin program, is that we have trillions of data sets. These are all very well tagged, and these are at different layers, right? And then and we can also get from multiple different sources. So the data not only comes from the ground, but also from multiple different sources, right? Satellite imaging is one major source for us, but we also have hyperlocal weather data, right, from different sources. We can get from either from IMD or from government sources, or through private players, right? Even in field, sometimes people go and take pictures, all of that, we bring that in, and then we train our models on top of it. And I'll talk about this later, but for example, currently an average field in India, for example, can be about a hectare, right? Now, the most challenging thing is it's not, I'm probably putting myself in a difficult situation when I say this, is that it's relatively simpler to solve problems in countries where the landholding size is very large, because, the current satellite images can be used because, they are large land and holding sizes, and mostly it's monocrop, right? So identification and analysis and all of that. There are other problems, of course, technology related problems, but these kind of fundamental problems they don't have. If you look at countries similar to ours, that's where actually we have major issue, because finding for all the insights for such a small plot of land, sometimes even lesser than a hectare of land, is really challenging, and that's why, we have to solve this problem, because the world will solve it, but India's problem and countries similar to India, only we can solve it, right? And then we layer on top of it, we can get different insights. We can identify the crop, the yield, what stage the crop is in, the stresses, both biotic and abiotic stresses, how the health is, pest and diseases, so all of this, here I talk about water stress, but it can be other stresses as well, right? And as I said, we can't do this on our own. And we do partner with, as I said, from the beginning itself, I would be probably naive to say that this particular problem can be solved by us alone, or that would be very also arrogant to say that, because it's not a problem for us alone. I think that's where we need partnership. We have worked with farmers, we have digitized over 8 million acres of land. We are present in 52 countries or 52 countries. All this, I think these statistics are also changing as we speak. We have actually also documented at least 388 crops with more than 9,000 different varieties. We work with more than 225 clients, and these are major, stakeholders who have been involved. Okay, there is a question, and in I think my colleague, Mr. Jitendra Kumar has also joined. So, Jitendra, if you're there, feel free also to, to maybe answer some of these questions. Jitendra is a very close friend of mine, very close colleague. I have deep respect for him. He's actually graduated from IIT Madras, and he worked in multiple different companies before he joined Cropin last year. As I mentioned at the beginning of the presentation, he joined as a product and innovation lead. But yeah, I think like Jitendra, and his expertise is in computer vision and text processing and NLP and things like that. So please feel free to stop me and add anywhere, Jitendra, where you feel I've missed out on something.
Yeah, sure. Thanks.
Yeah.
Welcome, sir, Jitendra, sir, to FTP program.
Thanks, everyone.
Thank you, sir.
Yeah, Jitendra has been also mentoring. I talked about fellowship program at the beginning. He's been mentoring a lot of interns, students. That's his main passion as well. So, you can reach out to him on LinkedIn. And also maybe he can add his email address or phone number, whatever he feels comfortable, or his LinkedIn profile on the chat window, and you can reach out to him. Thanks, Jitendra. And we are actually also, I want to mention that there was a GEF challenge, and now it has become last year, but actually like it's not very long ago, but in COP26, and which was held in Glasgow, we were named as one of the winners of Climate Adaptation Innovation Challenge. And this is very important because for the first time, we have worked with thousands of farmers, millions of farmers, but this is the first time that we are going to directly work with farmers and provide them with solutions for as advisory for climate adaptation, right? And that would actually be directly implemented, and we would start with a few thousands of farmers, and we are going to actually incrementally work with and increase it to about 100,000 farmers, right? So really looking forward to that. Okay. So now I'll go into the, sorry for, oops, I have to go back. Yeah. So I'll provide a little bit of background on Earth observation itself, if that's okay. If this has already been covered by previous presenters, I can skip this portion. But I can I'll probably just mention that we, while there are different, modalities of satellite imaging and also different applications for, the reason why they were also launched, right? Largely, like there is optical data, microwave data, hyperspectral, and there is other kinds of data, for example, for depth elevation map and creation, all of that. We primarily work with optical and microwave, little bit on hyperspectral for different applications. I will not be talking about hyperspectral today. Especially we work on Sentinel, Landsat, we have worked on planet data, MODIS. And these are our four major optical data that we work on. There are others as well, but for different applications we have used, but this is not that we use on a permanent basis. For microwave, we mostly work on Sentinel-1 data. I'll talk a little bit about that. There is a new, actually, NICER, which is coming. A lot of, Indian faculty and NASA is working together on this. a very good friend of mine, Professor Avik Bhattacharya, actually from IIT Bombay, is actually also closely involved with NASA and NISA on this particular project. And I think, like, maybe this is something very trivial for many of you, but as you know, the spectrum of electromagnetic waves and radiations, some of you know more than me because you might be coming from a physics background, is actually like wide. But we talked about optical data. The optical data is like looking at maybe like the visible light, right? And a little bit going into also the near infrared. So it's actually like, from high school physics, that it actually goes across the spectrum from nearly blue to nearly red. Sentinel-1 and radar data, all of that, comes somewhere here, right? So these are the primary two things, two electromagnetic spectrums that we work on, bands of spectrum that we work on, excuse me. But for example, there are hyperspectral data which can actually stretch even beyond, right? The more data doesn't mean that it's a lot of information. We have to look at, a lot of people think that the data means information. Sometimes, having a lot of data means that you also have to look at how to store this data, process this data and everything. So one has to be really, really careful when choosing also what kind of data that actually they need, right? So I talked about, two major sources, is both NASA and the European Space Agency. And this actually gives us a quick overview. I talked about the Landsat recently. There is also the Landsat 7 and there is a Landsat 8. There is SMAP, which we use as well. And there are many others, and I'm not coming from, I think Arvind can talk about this the whole day, but I don't come from Earth observation expertise. I'll leave it to Arvind actually maybe to take you through this another day. The ESA is like actually like their launching of satellites is more based on applications. So some of it was mostly for meteorological applications. This one was much more for user applications, and the other is for Earth exploration, right? The major user related, the ones that we work on is, the Sentinel, and the Sentinel itself is like split into multiple of them. We work on the Sentinel-2 mostly, and Sentinel-1, but depending on the application itself, like, you can have like different other, satellite images also. So these are all like there was a question actually on the chat window. So the satellite data itself is actually like freely available. The only thing is it does take us a lot of time, and we have built pipelines to process them. The processing pipeline details is currently out of scope of today's actually presentation, but I'll be happy to take that also through next time. So what we do is we actually, like, from the Sentinel program, we download the data and we use cloud storage as a basis. So we download it, and then, all the computing is done not in premise, but it's down on the cloud. So we process them and everything, and none of it is actually stored locally. So all of them are stored in the servers, and we make it available through our platform or directly to the user who are interested, right? Now, the training data itself is kind of like proprietary, so we don't open source it, because that would actually become very difficult for us. While our intent is actually to actually reach out and make this widely applicable, but data itself is difficult to make it open source. We have actually selectively open source data. So we partner with multiple companies and everything, and they want to evaluate our data, and we have made it open source. but maybe for select regions and everything, right? Not everything. That would be difficult. Now, there are a lot of applications of Earth observation to agriculture, and here are a few. So maybe before, I'll maybe quickly cover this and maybe also take inputs, because I don't want to put you all to sleep either, because, and I don't want this to be monologue. A lot of people tell me that, my way of speaking has actually a very relaxing effect on people. But I don't want that, at this time for you guys to doze off, but so feel free to add your questions. So what we do is while there are many applications, I think I've shown here, thanks to Arvind, is that what are the main things that we work on? Now, for example, when you look at, if you're given a satellite image, right, and if you work on Google Maps and everything, so these are not like the satellite images that we use are not like Google Maps. These are not RGB, although it's shown here as red, green, and blue channel. But these are not red, green, and blue alone. The optical data that I showed you before, that can have 13 different channels. So R, G, and B is only 3, but there can be at least 10 more. And combined with the radar data, we can have at least 15, right? So, and that's not all. If you combine the multiple different sources, and if you're looking at the whole Earth coverage, you can imagine the amount of data that we actually store and process, right? Now, what is important is you are given the raw data, and on that you have to draw the insights, right? So one thing which is shown here is we detect the crops, so let's say that you are interested in detecting the major crop in this particular region, right? It might be rice, it might be maize, it might be cotton, and once it is detected, and we can actually now this detection can be done over a period of time, and we can also plot the the evolution of it. We can see that there is with the onset of monsoon, in this particular district, for example, we know from weather that in this particular region the monsoon has started somewhere here, right? Early season. So you see that a lot of people have probably done pre-planting, pre-sowing. This could probably be because they have well irrigated field and all of that. So these kind of analytics also you can get, but most of them are rain-fed. They are actually rainwater dependent, right? So you see that the peak is somewhere here, and so you can actually you also determine the sowing calendar, and see this is, of course, there are a few of them who are done late sowing as well, right? You see a peak here, for example. These are things I think which we can go and investigate, right? So, but what is the fundamental thing that's required? And that's why I want to insist on it. The fundamental thing is crop detection. We can also look at weather-based studies, for example, once crop is identified, then we can look at the yield. So you see that this yield is overlaid on top of this particular, it's the same region, right? You can now, we see that there are certain regions where there is no crop, certain regions where crop is there, but, you can, in these regions, you can go and plot the tons, kilograms per hectare, of yield, right? And you can see that you also, we know that, for example, we have flood affected regions, you can go and compare what is the effect of flood on yield, the drop in yield. So these are some of the interesting insights that we can actually provide as well. Okay, this is a good question. Mr. Syed Nazimuddin, excuse me if I said it right. How do you provide your agri app-based solution to the farmers? Do you directly approach the farmers, or do you go to state or central entities? In what way farmers or FPOs can get your solutions? Jitendra, you want to answer that? Otherwise, I can also answer.
Yes. So, I mean, for the first part of this question, so we have the third parties in between. So, the farm owners, and through them we try to reach to the farmers. I think maybe few of the projects we will have direct kind of contact with the farmers also. But mostly it's like, say we give the solution to the enterprise and they basically pass it to the farmers.
So the way that we work is, I think, adding on to what Jitendra said, is that our application, is works through, for example, partner agencies. Like it can be either government, it can be NGOs, it can be even enterprise companies, right, who partner with these farmers, development agencies, right? And we provide our application to them, and they onboard the farmers onto this application, and the advisory is provided directly to the farmer, right? So the onboarding is done by, we require intermediate help. Once the onboarding is done, the solution is provided either mostly directly to the farmers, or through these partnering agencies, right, who also look at implementation and everything. Okay, but good question. Yeah. Yeah, Professor Ganesh. Yeah.
Yes, sir. I have a question. Say, assume that if I have a 2 acre of land, sir, I want to adapt your Cropin platform. What will be the pricing model, sir? If you are giving us a software as a service for 1 year, or how much will be the price for 2 acre of land, sir?
Actually, like, at this time, I myself, I don't have these kind of, I mostly take care of the technology side. Okay, but usually it's, it's quite tough at this time. Many of these products which we have provided, we provided as really at an affordable basis, otherwise, like, farmers will not be able to pay for it as well, right? We don't want the solutions to be away from the outreach of farmers completely, right? Because if something is too expensive for them, then they will not use it at all, and already there is so much of thing for them. So that's why, like, we prefer that rather than, I mean, most farmers whom we work with, we prefer that they work as an add-on service. Let's say that they are actually like buying seeds, so along with seeds, from the company which they are buying, they can also get these kind of advisories, right? Yeah, so I don't have per acre actually like values. Yeah, Jitendra, you want to add something?
Yeah, I mean, all the 3 parameters at least, which he said, so it's part of the financial. So like when we calculate the finance, so it based on the area. Okay. Which we want to monitor, and also the number of seasons we want to monitor, and it's just one time onboarding cost which basically comes into that.
Okay. Okay, thank you, sir.
Yeah, and yeah, I did. Thanks for adding in, Jitendra, also. So it depends also on what they're interested in, right? Some farmers, for example, they only want like one time, okay, tell me like, how my field is right now or what I should be doing, right? Most of them, they wanted on a periodic basis, right? Within a particular season, they wanted 3 times, right? Either in the Kharif or Rabi season, or annually they want, right? So yeah, here are a few applications. I think in the interest of time, I'll just skip some of these. It could also be used for soil moisture analysis, which is also an important product that we have developed using radar remote sensing. We can also have like, how much of, for example, along a river basin, how much of regions is affected by flood, right? And what is the effect of it? And how all of this also helps in understanding the future productivity of these regions, right? Like, for example, even erosion or inundation, right? Another important application is change detection. Forest change is change detection can be itself multiple. For example, we can observe over a particular season using both optical and radar data, how the crop pattern itself is changing. I'll show you a little bit about that later on. Now, these are actual images. The previous and the ones that I'm showing are actual images taken from the radar data, and also some of them are processed by us. And you can actually like observe, and you can see the difference between, for example, cropping pattern, like before sowing, after sowing, mid-season, after harvest, all of that, you can find a difference. And how much of it is harvested, how much of it is left harvesting, those kind of, like, and that also helps with supply chain management. That's like something like, so our crop, the land use monitoring and crop identification are the two major layers that we have to use, satellite imaging, and we use satellite imaging and machine learning for that. And once that is done, we can do all kinds of insights on top of it. Once the crop is identified, we can exactly know, because you have to, why is that important? Because if you're not able to identify a crop, then you assume that, based on the optical data or based on the spectra, you assume that a certain crop is already probably has reached, is still not reached its maturity. But in fact, if you have identified the crop, it might actually be in the mid of its, maturity, right? Otherwise, you can make the false assumption that it's not actually like, it's still growing, right? And then you find that the curve actually like already starts falling down after a while. And then that's when you realize that, oh, actually like the crop has already reached its maturity and it's going now into senescence, right? So these are the important things. So I think the most, and that's why this title of this is on crop mapping, because a lot of people map land use, but crop mapping is something which people don't talk about, because stage of a crop, phenological stage of a crop is really dependent on identifying of the crop. Change detection here is one example here used is forest change detection, deforestation. For example, WWF was interested in knowing and identifying how much of the forest area has been cut for agriculture land. So we can also make those kind of, so these are hotspots, which we have actually which we have done also. And later on, it can also be on fire monitoring. For example, forest fire is like not only forest fire, but stubble burning is also a big problem. So these are all directly impacting also the environment, and these are very, very important to monitor. Okay, I'll just now maybe accelerate a little bit. I think I have another 20-25 minutes before to conclude this. So now I talked a little introduction of Earth observation and what are the kind of modalities of images and that we use, and we also have to, so while AI and machine learning is an important piece, I'll also talk about that. How we manage the data and how we do the computing is primarily more important than the machine learning model itself. And I cannot, these days I've been insisting on this. I think it's in the whole, this whole hype of, excuse me for saying this, but it's the truth, the whole hype of building solutions based on models, based on machine learning. I think it's exciting for everybody, but in that process, we have missed out on something very, very fundamentally, very, very important, is that model building is only one part of the solution. At the beginning of this presentation, I said that technology is only one part of the solution, but even in technology, machine learning model building is only one part of the solution. How we actually, what kind of data that we collect from the ground truth, from the ground, how we annotate, process it, combine it with multiple different sources of data and make it ready is the most critical element. Now, after that particular, and I think like 80 to 90% of our effort is actually spent in this very, very important step, And unlike and that's why I think these kind of interactions between academia and industry is very important, because there is this false idea and maybe hyped up idea that model building is the most important thing. I would actually now more and more, I'm not the only one. I think more and more people are realizing that data and computation is the most important, but model building is important, but it is not the important piece, right? So data becomes a central piece, and then computing. So all our processing is done on the cloud and also storage, right? And then we have also workflows, right? Like how we start from, we download the data, we process it. You have to understand that it has to be clipped to that particular plot, right, that we are interested in. So you get the satellite images are downloaded as tiles, right? I think the earlier speakers might have mentioned, and these can be like, 10 kilometer or 100 kilometer by 100 kilometer, no? So those have to be actually like clipped to the plot that we're interested in, right? And then we actually like run it on our own workflows, and then we process it, and it goes through the whole pipeline. And then is actually also the what do we do about it? What kind of solutions we use, which is based on machine learning. I'll unfortunately for this particular talk, I'll not be talking about the data and the computing, because I've been asked to talk on machine learning and AI, and I'll focus on that. Right? Okay, so just a rain check on the time. I have another 20 minutes. Has machine learning and AI background been introduced before? If it isn't introduced before, I think it makes my life very easy. I can just skip some of these slides. Yeah, just a question to the audience, like has machine learning been and AI been covered before, like to this faculty?
Yes, a little bit we covered. What are the types of machine learning? What are the different? Little bit we covered. Theory part we covered.
Okay. So then maybe some of it might already be covered here. I think like largely like, but I'll still mention that while machine learning, the core of it is like, there are multiple different elements, and people like, like to always like to group and cluster and everything. There's this idea of unsupervised learning, supervised learning, and reinforcement learning. Okay, there is a question. Do you use automation or AI to bring out ARD, analysis ready data from the various types of collected data? I think like, after a certain while, yes, we automate our workflows. At the beginning, it's very difficult to automate it because it takes time to understand our data and ensure that once we understand it and once we know how to make it, now, the pipeline, you just launch it and, it brings out the data that we want, right? It's not only analysis ready data, but it's from end to end, right? Until reporting and also like any insights that we want, right? Like it completely runs on our pipeline, right? So that end-to-end solution is all completely automated, and it becomes even, I mean, it's a good question, because some of the ways, it's also very important to bring learning into the whole process itself, right? So there are, I can't talk too much about our proprietary algorithm, but in the whole process, the processing pipeline also, like some of the things which requires actually like manual, as you understand, right? Supervised learning sometimes is very manual, right? When you build the training data set, it has to be actually like built by annotating every single point of data. It's very, so we have automated all of that, and we have also brought learning systems into that, right? A lot of the reason why I wanted to focus on this, a lot of the earlier problems was focused on supervised learning. Recently, I think reinforcement learning had also come into attention, mostly for gaming and other environments. But, unfortunately, unsupervised learning was always like, seen as the black sheep, or the guy we don't talk about, right? But, I would like to mention that although this was seen as something very, very preliminary, now people are going back to unsupervised learning because they're understanding that supervised learning is very, very very data intensive and very cumbersome, how to annotate how to annotate the entire earth, right? How to annotate it for a period of time. It's very hard, so now people are understanding that the solution might not actually be in supervised learning, but and not completely in unsupervised learning, but somewhere in midway, the weekly supervised learning, we call it, right? So I want to also give you some insights. These are maybe insights which you would not get otherwise, but it's also some treat that I want to give you. But focus, if you want to shift in this area, focus also more in unsupervised learning rather than supervised learning. That would be my Easter egg, if you may, right, of this particular presentation. Okay, I think I think that this is supervised learning. I'll not cover it. There is also one more thing, one more important aspect which I want to talk about. A lot of the students, and you as a faculty might also be seeing this, machine learning is not something recent, right? Like I started actually building my first models even early on in 1999 or maybe 2001, so almost 20 years back, right? This pattern recognition, these are all very old problems. It was academically present, but it was never actually brought to mainstream, for using. The reason why suddenly, there is this thing is this because of this deep learning boom, right? Which happened, somewhere in the mid of last decade. And now what has happened is even right now as we speak, a lot of the students, they are only interested in deep learning, but it has a lot of foundations. I think foundational knowledge cannot be neglected. Everyone wants to work on deep learning, but there are very, very few problems. Deep learning, you have to understand, is very, very data intensive, very computation intensive, and it's very hard to also interpret as well. While it's exciting, no doubt that it's interesting, one has to understand that one has to go back to the foundations and work from there, right? Not every problem can be solved using deep learning. Okay, I'm having a lot of questions. Oh, okay, it's just some
that is related to feedback.
Okay. Right. So again, I want to, maybe if there is one thing that you can probably take back from this particular presentation, is that as I mentioned, maximizing. See, if you want to actually so what actually happened is, over a period of time, people started focusing on data. That's when the big data boom came. Everyone wanted data. Okay, let's collect a lot of data. And then what they found is, once they collect the data, they found that what to do with the data now. You've collected so much amount of data. Then they said, you have to manage it and then make it available. So at that time, they were saying that don't worry about it. Collect all the data, because computation will catch up, machine learning will catch up, and everything. So now, we found to manage the data became difficult. Then over a while, the value maximization we could find, but it got saturated after a while. Why did it get saturated? Because, our algorithms, the models and everything were actually had reached a point of saturation. Now, if you want to actually go beyond this saturation, the only way for value maximization is to go back and change how you actually look at the data. Maybe even work on this data collection strategy itself, right? And go back actually. And it involves, I think one of the often neglected field is that people think that, oh, I'll do the modeling alone, right? No, how you collect the data and how you manage the data and how you make it available. Machine learning is only maybe 5% or 10% of the work. The bulk of the work remains in the data management, the data collection. If we neglect that, then I think it's probably anything that we build on top of it will not be effective, will not bring value. so we have to solving with the end in mind. I have only 10 minutes and I'll try to see how to cover, because I have, I made the slides for 2 hours, but I think because of availability and everything, it got shortened. So I'll see if I can actually shorten this further and directly approach, what I wanted to cover is that while we talked about data, right, the importance of how data is, annotation of the data and everything. And, the past speakers might have talked about theoretically about machine learning and also about supervised learning and everything, right? So even making that data available and all of that should be the major focus. Let's say that I have the model, I give you the model, right? Once the model is given, there's not much we can do to, on top of it, because I don't think any of us in this group is going to really I mean, maybe there are, few of us, I don't want to generalize, but for the major portion of us, maybe we are not going to build that model, which is going to be, really the most innovative model, right? We're going to use models which somebody else has built. So if you fix the model, then what is the one thing that you can do differently is actually look at the data, right? And I've insisted on this a lot. So when we look at the problem first, then we, so the problem has to be looked, the data has to be looked, and then we are talking about the model, as they say, don't put the cart in front of the cow, or the horse, right? The horse, what is the horse? The horse is actually the problem that we are trying to solve, that has to be addressed first, and that could be about let's say that they are interested in providing loans, people have been starting to look at really the impact of a farmer for carbon storage is has been really started looking at. People talk about climate change, but we also currently have statistics on how even a humble farmer, they're actually their field can actually store carbon, and how it is actually one of the most earth climate change barriers, the farmers. And it's less understood, right? And I think that has to be, credit has to be given to them, okay, there is some question. Jitendra, did you want to address that?
He's answered, sir. He's given the answer for the commerce related.
Okay.
Yes, given the chart window. Yes.
Okay, right. Thanks, Jitendra. Thanks, Komal, for the question. And then, we have also a lot of data points. And I think you can get, now there are also a lot of open source data, which is annotated data. You can just search for satellite image and annotated data or open source data, and you'll find a lot of resources. One of my friend Hamid from Radiant Earth Foundation, has been open sourcing data. You can actually download that, use it on AWS, download it onto your S3 and process it as well, right? Then we build actually also models with context, right? Like crop identification, soil health, yield prediction, disease early warning, and abiotic, right? Stresses. So this is where actually much of our focus goes into, and obviously agriculture, there are a lot of problems to solve, but we want to focus on that and then look at what the data, which kind of data we have to look at, either ground data or both, some often earth observation data. And then we look at what kind of models we can go. So don't focus on your models alone, focus on what are the problems that you are interested in solving, because these are very, very crop diversity protection, right? This is very important. Soil restoration, a lot of farming is intensive, and we have to look at how, for example, crop cover, right? How to bring in crop cover for protecting our soil during, not just leave it barren. We have seen, I can show you actually, I can show you some land use, land classification problem where people have left, yeah, this one. For example, this is results of Shabri's work, and, people have sometimes left land barren, right, for particular seasons, and we know for now that leaving soil barren is not a good idea. Just have some kind of cover crop and to restore the fertility, and then, then actually like do another crop, right, the next season. So these are, I think, like, I mean, for this particular group, I don't have to talk about the importance of all of that. But this is, one example where, for example, in a particular pin code, we have been looking at the land use land classification problem, but this is for a different use case. It's not like trying to find out from remote sensing what is the urban class, what is the water body. These are very simple problems to solve. We want to know, like, once you have identified a field as agricultural field, after that, right, what is it, how much of, I talked about harvest detection, right? Harvest detection. So then we have to know, like, how much of it is still standing, how much of the previous crop is still standing. For example, in January, we see that this is a very difficult problem to solve. We still see that, and this is an actual graph from actual map from our results. We find that there is still some crop where the Kharif crop is still standing, some plots, right? You can zoom in and see these are actual plots, right? So we clip them from the satellite, we process them, and we find, right? Some of them are long-term crops, right? Some of them, and by the time February comes, you can see that certain Rabi crops have already been harvested, right? Some of them, they are Kharif, you can see that from the standing crop, they have changed to pink, which means that it's the crop is harvested, but it's left fallow, right? Some of them are actually, that season itself is kept barren, right? Or it is actually like maybe that particular region it's not an agricultural land growing area itself, right? So I'll just maybe quickly talk about also the importance of, so land use and land cover can be for different applications. Okay, I'll just answer some of these questions right now. Now, we know that, for example, why land use and land cover becomes important, because we can also study the effect of change in land use patterns and how that's actually contributing to climate change, right? There is this particular study which was actually done in Eastern India. I really suggest, it's a very nice study which has actually found that the largest change is linked to vegetation change, right? And almost 25 to 50% is associated with land use and land cover change. So this is an interesting study. So there is, but at the same time, there is also natural land change. For example, here, because of going from one season to another, because of the monsoon and then coming to the summer season and then switching back, there is a natural cycle of it. Now you can also see if it is actually deviating from these natural cycles, right? But there is some which is anthropogenic changes. For example, this is from Amazon forest, which you downloaded. This is from NASA. You can also go and see that between 2000 to 2012, you can see the changes. Intermediate in 2006. In 2003 alone, 67,000 square kilometers of land in Amazon Amazon forest was cleared. So I think, like, this is maybe a little bit more technical, but I don't want to get into this. And I just gave you a glimpse of it. I talked about the Easter egg in this particular presentation. And I think I already gave it out, because you don't have to now, go back and, like, try to figure it out. But I think we should stop thinking about this whole problem as a classification problem, right? It's no longer a classification problem. It's a question of, I am given some images, right? And I want to actually find out what my use case is, right? And my use case could be like land use, land cover. It could also be crop identification. It could be yield, right? Anything. So here I'm showing an RGB image, but it could also be multispectral, right? And what am I interested in? Now, somebody would say that I'm interested in classification. No, I'm not interested in classification. I am interested in finding a representation of my original space, a new representation space from which I can get any interpretation that I want, right? Sorry. that any interpretation that I can actually make, right? And so we are actually like going from, so the earlier paradigm was on, you take the unlabeled data, you ask some people, random annotators, to actually annotate the data, bucket them into multiple different classes, and then you train your model and everything, and then you make the classification, right? Those are the ML classical way of looking at it. But I told you that for a long time, because we had been so much focused on supervised learning problems, we lost a lot of time and effort into that we stopped building products, solutions on unsupervised learning, right? And that's where actually the whole this whole AI space is also moving. I can show you like very results, like for example, this is some simple land use and land cover, and even for agriculture crops, right? We have this, you can have like very high accuracy with supervised learning problems itself. This is from my own research work. You can classify the different lands and everything, but in practical situations, like even if you hit 85% of accuracy, that's very, very good. If you're able to identify a crop using 85% accuracy, never go for like more than that, because in practical solutions, you will not be able to scale them. You will not be able to take it and say, oh, it works everywhere, right? What is the most important thing? You want to build models that actually scale, that actually like also can be used widely, right? So I talked about this one. So I think the next big paradigm is also on learning representations. I'll not, you can see that even without supervised learning, you can actually like, this is something which I, just as a group together, and then I gave labels to it, right? I think I can go on and on, but I think I'll stop here because I think I'm also out of time. We started, I think, at 11:22 as well. There are some questions, and I wanted to also talk a little bit about crop mapping. I will play this video and then. I hope you're able to hear.
So no voice. Oh, okay. Done.
I'll stop it there, and maybe in a few seconds I'll need just to also show how, for example, this is actually what you see here is our platform called Smart Risk. I hope this is visible.
Yes.
You can actually like so this is all done ahead, you can, for example, look at the land use and land cover. Here it is, what is shown is how much of land in this particular district of Bahubali in Maharashtra is actually like agricultural land versus non-agricultural land. And then you can actually go and look at the crops, right? For example, what are the different crops that are grown? What is the yield? You can also look at, for example, water stress, right, in this region. For example, this is in 2020, May to October. These particular regions had like a lot of stress. All of this is evaluated, it can be classified as mild stress, moderate stress to severe stress, yellow, orange, and red, right? These are insights I think which, we can talk about later as well, the yield related studies. Sorry, there's some problem loading. Okay, I think some issue with the so yeah, I think, and this can also be studied over a period of time, how it changes, right, from different seasons, from Kharif to Rabi, or Rabi to Kharif, and you can also see like which are the, you can also go and see which are the crops which are grown in this region. Excuse me, dominant crops. These kind of decisions also can be observed, right? So I'll stop here. Jitendra, did you want to add anything before we conclude? Like,
yeah, I mean, no, Praveen, widely this time everything is covered. It's like we are also, I mean, just to give a highlight, we are also working on one of the larger thing where we are trying to bring all the expert knowledge also into the system. So the data-driven models which you have seen, that will also have additional informations from all the like expert knowledge systems. So this will help in bringing the agronomy knowledge into the along with the data into the model.
yeah, thanks, Jitendra. So adding on to what Jitendra said is that there is data, but there is also a huge amount of knowledge which is there, which we have also, which we have built over a period of time. And this is like, this is something ingrained, but now how to marry this together and automate that whole process. So knowledge, adding of knowledge is actually just like ground truth data. It's a very manual process of building and bringing it. How can all of that be brought together in automatic fashion and integrated with our models? So we are building one of the largest ag knowledge systems, and Jitendra is leading on that. So I thank you everyone for this, and thanks Jitendra for joining at the, as the last minute as well. This is his passion, so I thought he would be really interested in. I couldn't message him before because I was, on sick leave. So I thought that he will, he'd be interested also in joining. So I'll conclude here, and thanks so much to everyone who gave their time.
Chat box, they ask us questions.
Praveen, I think there is one question that also in the direction of summarizations only. What are the main key points from this talk? Okay. Other questions I have tried to answer, so I was typing meanwhile.
Sure.
Yeah. So I think what I wanted to mention first of all is that, the major point that I have foreseen is that whole agriculture is actually going through a transformation right now. And we are actually moving away from this intensive agriculture to agriculture which is more sustainable, restorative, both for ourselves and also for Earth. And in that, the most important thing is to actually identify, right, how the different crop patterns and everything look like. And, one thing which I want to insist is that technology is not the only thing that's going to solve all of this problem. We have to understand that there are other elements to this, to bring this together, right? Which is also on how different entities can come together and collaborate together, bringing a behavioral change, right? And how we actually cultivate crops, and also how as consumers we take in crops, right? Take in food. So all of that has to come together. And the reason why I've mostly focused on remote sensing and Earth observation and machine learning today is because it actually, like, if we talked about the multiple different sources of satellites and the data coming from it, and they mentioned also that our focus earlier was only on machine learning, but we have to also know that data and computation also becomes primarily important. In fact, that's 95% of our time should be spent on that and not on model building exercise, because model you can find anywhere, right? So the data and how we process and make it available is a fundamentally important thing. Crop mapping becomes, so a lot of people talk about, and why satellite imaging? Sorry, that's something which I missed. Why satellite imaging? Because, field scouting is a very, very expensive process, and if we want to scale this up, how much of land can we go and scout and survey and analyze, right? And that's the reason why, if we can actually like solve, I don't say that Earth observation is going to solve 100% of our agriculture related monitoring issues, but if it can at least like solve 70% of it, that's already really good. The rest 30%, even 60%, if it can solve, that's really, really good, right? Because the rest of the 30 to 40%, we can solve it using other means. We talked about multiple different satellites and also processing pipelines and everything. And we talked a little bit about land use and land cover. And land use and land cover is not only about putting it under different buckets of, saying that this is urban area, this is water body as against, but also, like once we have the satellite data, we can add different layers on top of it, how the land use is used, even within agriculture field, how the land use patterns is changing, right? We can also have for other applications like change detection can be used for forest intrusion, for forest fire mapping, these kind of things. So these are all different models that we have built over a period of time. And Jitendra talked also about, most importantly, about agricultural knowledge. There is data, and we have been a lot focusing on data, but how do we bring this whole body of agricultural knowledge, which we bring it because we bring it through our own experience, through our own intuition to build these models, but how to bring that together, how to store it, how to process it, how to make it available automatically without any human intervention, that is a big challenge. Then we talked about different learning problems. There is supervised learning problem, unsupervised learning problem, and also reinforcement learning problem. A lot of the earlier problems we have been focusing on supervised learning problem. The next paradigm that where we are going to focus is going to be either on unsupervised learning or weakly supervised learning, moving from weakly supervised to completely unsupervised learning problems. I think that's where the shift lies. I briefly showed you some results which we have had, and also some practical applications, in form of smart risk platform that we have built, how we can monitor, different kind of, in different areas, and different states and different geographical locations by using these the satellite images, right? So I think I summarized most of it. I don't know, maybe I missed out on a few, but as I said, this was actually like made for, I do have many other slides to cover, but this was actually made for 2 hours and just of time. I think I had to shorten it. There are other research problems which could also be interesting, which I'm happy to share at another time. I have shared with you also the Vinay, who is our focal point for any HR related questions that you have. And you can reach out to him for our fellowship programs, for our full-time positions, where we are really looking at bridging the gap between between us and the people whom we are reaching out to, which is the farmers and those who are supporting the farmers, right? So thank you so much, and thanks everyone for listening.
Yeah,
Thank you, sir.
thank you, Praveen sir. Sir. Thank you, Praveen sir and Jitendra, for this time, for a valuable time, sir. So we'll keep in touch with you for further collaborative work, sir. Maybe some other session also we'll schedule, maybe for student, maybe we'll invite you for campus also. So we want to really learn from you, this Cropin technology. There are a lot of things you are doing. So with the short time we have learned something, but we have to learn some more things, some more detail for your company, sir. Now I'll request Venugopal sir to give part
Yes,
one.
So thank you, sir. Praveen, sir. It's a wonderful session, sir. Informative session. I hope maybe all the participants also enjoyed. Maybe they raised, they clarified many clarifications, doubts, and the way how you started regarding coding of cares something about crop mapping using AI, that remote sensor topics, how you covered with the example by showing images and by showing some video. It's a wonderful session, sir. Hope IAPM always happy to collaborate with you, sir. Further research, further any programs. We would like to invite you, sir, as our Ganesh has said. And thank you, sir. Thank you very much on behalf of FDP team.
Thank you, and have a very good day, everyone.
Thank
Yeah,
you, sir.
thank you, everyone.
Thank you, sir.
Jitendra,
Jitendra, sir. Thank you very much for your support. Also, always just you are giving whatever respond to the participants through chat box. Hope they also may be given your feedback. Thank you, sir. Thank you very
Thank you.
much,
Yeah.
Praveen sir and Jitendra.
Thank you, sir.
Thank you, sir.
Bye.
I'll call you, sir. Yeah, sir, participant, the afternoon session will start at 2 o'clock by source space. Please come on time. We'll start exactly 2 o'clock. Okay.
Yes, sir.
This will stop here and we'll meet at 2 o'clock.
Okay, sir. Thank you, sir.